Alkanes are hydrocarbons that contain only single bonds. Alkanes are said to be saturated hydrocarbons because their hydrogen content is at a maximum. The general formula of alkane is CnH2n+2. The names of alkanes all end in A, N, E. Here is a list of the first 10 alkanes. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. An alkyl group is formed by removing one hydrogen from the alkane chain. The removal of this hydrogen results in a stem change from An to Yl to indicate an alkyl group. For example, CH3 is methyl. C2H5 is ethyl. C3H7 is propyl. The name of every organic molecule has 3 parts. The parent name indicates the number of carbons in the longest continuous chain. The suffix indicates what functional group is present. The prefix tells us the identity, location, and number of substituents attached to the carbon chain. Guide to naming alkanes. First, name the longest carbon chain. Then, the carbon atoms in the longest chain are numbered. Next, give the location and name of each the substituent alphabetical order as a prefix to the name of the main chain. Lastly, combine the longest chain and substituents into the name. Nomenclature IUPAC system. Rule number 1, name the longest chain. The longest continuous chain has 4 carbon atoms. Thus, the compound is named as a butane. Rule 2, number the longest chain. The carbon atoms in the longest chain are numbered. The numbering is started from that end, which will give numbers having the lowest value to carbons carrying constituents. Rule 3, locate and name the substituents. The attached group is located on carbon 2 of the chain, and it is a methyl group. Rule 4, combine the longest chain and substituents into the name. Thus this example is 2-methylbutane. Rule 5, use prefixes di, tri, tetra, when there is more than one alkyl branch of the same kind. Alkanes undergo combustion in the presence of excess oxygen and are completely oxidized to carbon dioxide and water with the evolution of a large amount of heat. Halogenation of alkane is the reactions between alkanes and halogens mainly concentrate on chlorine and bromine, in the presence of UV light or high temperature to form haloalkane. Mechanism of halogenation involves 3 steps of free radical substitution. Step 1, chain initiation step. Heat or UV light cause the weak halogen bond to undergo homolytic cleavage splitting to generate 2 halogen radicals and starting the chain process. Step 2, chain propagation step. A hydrogen atom is pulled off from methane, leaving a primary methyl radical. The methyl radical then pulls a free radical halogen from Cl2. Step 3, chain termination, recombination of 2 free radicals.